Hello, everyone, and welcome to what has been highly anticipated in my book, the Great Brick Labs Live for Big Robot. The code name of Big Robot is the project for artificial intelligence sorting machine that we are going to be building over the next 12 weeks. I would like to very quickly get into an introduction here of our main developer. This is Amanda. Hello, Amanda.
Hello.
All right. So, kind of a little bit of a backstory. I'm going to let other people kind of get into the live. We will do some Q&A. We'll definitely take questions. I'll moderate the questions. The way this is going to work is I'm going to go over kind of who we are, why we're doing this, and what we hope it to accomplish at the end of it. And then Amanda's going to go through the CAD design. This is a design meeting going over the actual design of things. Then we'll kind of go through different iterations she wants to review, and I'll ask her questions and even some things that she's done that I haven't seen yet. So I'm going to be surprised by a few things. So that'll be fun for me. Then I will go into what we need, what you can do to help, what we're planning on doing next. I got a few areas in there, and then I will make the announcement about how the next live is going to come up. So welcome. Thank you for joining us. Again, my name is Chris, and I am the owner operator, mostly operator of Great Brick Lab, a nice little Bricklink store, Brick Owl store in Illinois. I'm really happy to be able to operate that store, and we've been able to acquire a pretty good amount of bulk Lego. And a few years ago, maybe about a year and a half ago, Amanda almost joined our team and said that it didn't really feel like it was her for just to sit around and sort Legos all day. She felt like she could be a lot more productive than that. Came back to me and said, well, I do want to be engaged in the organization. What if I did something like sorting automated? And I was like, what does that mean? And so here we are about a year and a half later from that journey that we have come on, and now we're doing into this. So that's who I am. Amanda, would you like to let people know who you are?
Yeah, so I'm Amanda Yarflin, and I come from Illinois as well. I came on board with this project with a background in the First Tech Challenge, which is a robotics program for high schoolers to get engaged in engineering. So I had been on a team in Bettendorf for about 5 years prior to starting this project, so I had quite a bit of experience with design and manufacture and a little bit of coding as well. Um, so this year I've gotten a lot more into the design of the robot as I came to understand the goals of Chris's company a little better and understand what kind of robot system would help him the most.
All right. Thanks for that introduction. I'm going to give a quick shout out to those who have joined us. Micah Ken, Daddy O's Bricks, Bill, the Brick Room, Robert Sanders. Thank you so much for joining us on this live stream today. So that's kind of who we are. Now, why are we doing this project? Well, one of the reasons is definitely on a business aspect from my perspective. If I was able to accomplish one of the sorting stages of our Lego and do that in an automated way, that would definitely achieve a higher business goal for me. But I think for Amanda's why to do this is completely different than me. Amanda, what do you say when you kind of ever ask that question, why build a robot?
Well, I agree that it's a good thing for the business, and I really love the idea that will help improve your productivity. But beyond that, I also think that it's a great experience for me and also the other members of the Lego store community to be able to learn a lot more about technology and what it can do to help them, and also like more technical aspects of what it takes to build something that has to handle such a variety of different shapes of objects.
Oh, there's plenty of variety, isn't there? And I remember
Yes.
we met recently, and I brought out a Thanos or a Infinity Stone ring, or a stone for the Infinity Stone gauntlet. And you were like, "That's a Lego. It's tiny. It's like one of the smallest Legos that I know of." And they get lost all the time. There's a few, maybe a little bit smaller than that, but we're not really trying to build a robot to handle everything. But how do we address things that might come through the machine if you just pour bulk into the device? Okay. Next, we're going to talk about kind of what we anticipate in the end. As you have mentioned, if you probably heard or even just seen in the description of this live stream, in the end, definitely, I would like to have a production working prototype of this robot. But the design and the artificial intelligence, anything that's developed over the next 12 weeks and the contributions that are given by different members inside of our Discord will be made available as open source. Amanda from the very beginning said, if we do this, I want to be able to give it away. And she already kind of alluded to that a little bit and said, this is for the Lego community. This isn't something that we're doing just from a business aspect, just to keep it in-house. We really want support. We want to share this with the world. Definitely are looking forward to doing that. Okay, so are you ready to go into some of the CAD, or if you want to go over the design some?
Sure, yes. So I actually, back in 2021, I did a little bit of building with Lego, and I was sort of drawing on the idea that, oh, we could make something with Lego like the original world's first Lego sorter. But I kind of ran into problems with scale there. I couldn't get it to be as big as I wanted, and I kind of ran out of time before I got it running. So this year, I came to Chris and we talked a little bit more about our goals. Before our first meeting, I came up with a design, and you can share my screen.
Sure.
But I came up with a design for a slightly bigger, but not very big model that would sort Legos using a carousel system. So this would rotate the bins around, and there would be a bin in the middle that the Lego would drop into, get detected, and then use gravity to fall into the correct compartment. After my meeting with you at the beginning of summer, I scrapped this idea because it was going to be way too limiting in how I could scale it up as well. So, and we had some discussion about speed as well. Mm-hmm. We wanted to be able to sort around 2 parts every second so that we could sort an entire, 40-pound bin in less than a day. So I came up with a new design that uses air. We will be using compressed air, and we'll be running it through solenoid valves, which will open and close depending on whether the part is in the right place to sort. So a row of parts, imagine a row of parts comes onto this conveyor belt. As soon as the camera detects what the part is, it will basically store it as being in some location on the belt. And the motor running the conveyor will turn, and it has an encoder on it, so it can basically detect how far it's rotated. And since the camera knows, since the computer running the robot will know where the part is, it will just wait until the motor runs a certain number of rotations, and then one of the valves will open and the air will propel the part off the belt. Following this sorting system, we will have, and I haven't gotten to design this part yet, we're trying to work with Chris's brother on the final stage of the sorter. But after the air valves, we will be having a system of gutters that go down to a shelf below the robot that will contain the 16 bins for each of the 16 categories we'll be sorting into.
Yeah, this is a version of the design that I have not actually seen yet. I think you went to the end game here quickly.
I did. I'm sorry. I can actually back up this. Onshape has really good version control, and it actually
So I will I'll
maintains.
make one comment. So we are using Onshape. Let me ask you a question, Manny, because I'm not really familiar with Onshape. If I'm a designer and I find out about this project and I want to help and contribute, is Onshape a tool where somebody could come in and help create iterations or versions, or maybe I could come in and grab our design from Onshape and just run with it on my own? Is that something that would happen there?
Yeah, so Onshape is entirely on the cloud. So people can share models with the whole world, and anybody online can just go to that model and access it.
Okay.
In fact, if I go into other documents, I can search for literally anything. Like I can say T handle, and probably somebody has modeled one, and like there's so many parts that just people have made, and you can find all of them if
Were
they're
you
public.
were you able to find some of the things that you needed in there?
I'm actually part of a team called FTC Robotics Parts Users,
Mhm.
and this is just commonly used parts in our robotics competition.
Mhm.
And this is stuff like these motors that we use on our robots, and also the hubs that go with the shaft on the motor. So
Mhm.
I use that library to find some parts for our robot. Yes.
Okay, so Robotics League, right? I think people might be a little curious about that. Can you give me like 30 seconds on Robotics League and your involvement there?
Yes, totally. So I'm involved in, it's called First Tech Challenge, and it's a very holistic program where we not only build and design robots for a different game every season, but also we help other students learn about technology through outreach projects. So teams basically start by either having a school sponsor them, or uh, tech companies in the area can sponsor teams as well.
Mhm.
Um, and and we basically compete throughout the entire school year
Mhm.
to hopefully reach the world championship.
Mhm. Mhm. Now, one thing I'm going to say, because Amanda's quite humble about this, but she did go to was it the championship this year?
Yes.
The
So
national championship.
kind of like sports at the end of the season, all sorts of teams from countries worldwide come to the US to compete at one major competition. It's
Mhm.
about 4 days long.
Mhm.
And there are teams from all the different levels of the first program. So some teams are high school, some are junior high, and some are older,
Mhm.
like college students. So it's really exciting to get to go there and see all of the different countries
Mhm.
coming together. And actually, this year, a team from Romania won our league
Oh,
championship.
well, congratulations to that team. I'm sure you give them a hard time, or at least they look good competition.
Yep.
Okay. So now I'm going to lead into your experience in the robotics league. Definitely, would you say had a huge impact on being able to get to where you're at with the design?
Yes, absolutely. I don't think I would have had the confidence to come to you and say, I'm going to build you a Lego sorting robot if I hadn't done the
Mhm.
first tech challenge beforehand.
Mhm. Okay, great, great. Okay, so what are we looking at right here? Is this iteration number one?
Yeah, so I kind of call this iteration two, following
Oh,
the
okay.
silly
Okay,
carousel
so
one.
the carousel was one. This is number two. Thank you. Okay, so on number two
Yes.
here, so we'll try and move to the new one since you've already revealed it. But let's take a look at number two here and say what is working with number two and what is not working with number two and why you went to number three.
Yes. Okay. So for to start out, we have the same sorting end system, sort of. I have the same pneumatic system set up to shoot the parts off the conveyor. But prior to that, I have this cone-shaped part, and the Lego was meant to shake off of this vibrating V channel
Hmm.
that you might recognize something like this from other people who have made Lego sorters.
Hmm.
There's this vibration channel here that
What was
tries
the
to
what was the term you used previously? You said something. It's a Brazil what?
it so there's a thing called the Brazil nut effect, and so small things like peanuts usually go to the bottom of the mixed nuts, and big things like Brazil nuts rise to the top.
Hmm. So in this
So
particular V channel, something big is coming up to the top. Maybe something that's not good for the cone. Perhaps a person would be standing there, maybe pulling that off.
yes, that's possible.
Okay.
In once I actually remember to do this, we are planning to add sort of holes in the base of this V channel
Hmm.
to allow the tiny Thanos gems and friends lipstick and really tiny little parts to
Hmm.
just fall through.
I love it. I love it. You went to very specific elements. So we're talking about Friends lipsticks. If you're familiar with Lego at all, and I hope that you are, if you're coming to view this, you got the Infinity Stones. You probably are also going to be familiar with the plumes and the feathers from some of Castle and Knight sets, or maybe Forest Men. Those things are just so tiny, and we've agreed that we don't want those trying to go over belts. Is that what the problem might be?
Yeah, so the main thing is that it's difficult to seal off the conveyor belts. All
Hmm.
the conveyor belts need structures holding them on to the
Hmm.
rest of the robot.
Hmm.
But between the conveyor and the structure, it's difficult to keep parts from trying to sneak their way in. And as you
So,
can see on this version, I put like a piece of metal here to try to stop that. But
hmm.
small parts are going to be a challenge.
Right, definitely. Small parts are going to create a challenge, and I think we add that to our challenge list. And if somebody comes on board says that they have the solution for that, that's where a person who's we've already reconciled that that's a challenge we're not going to overcome. So we're going to try and eliminate those small parts ahead of time. I do see some questions in the chat. Thank you for those questions. I'm not going to ignore them. We are going to get to those at the appropriate time. We're just going to continue the flow here on her iteration number 2. So we've gone down the V channel. We've eliminated the small parts. Now we're on to the belt. What's next?
Yeah, so this belt is set up with a gearbox so that the first belt will go this way, and the second belt will go the opposite way,
Hmm.
so that the parts will approach the spinning cone. So this cone is attached to a motor that's actually mounted under here.
Hmm.
So the cone was supposed to try to narrow the flow of parts. So if there's multiple parts next to each other, it will kind of push one will go through, and the second one will have to wait,
Wait its
basically.
turn. Right, right, right. Because it'll rise up the cone, and it can't get two of them on that small space, right?
Correct. Yes.
Yeah, it looks like that might be a little bit limiting on some of the larger, even just like maybe like a 4x6 brick or something like that. Might not even make it on that belt at all. It might just continue to jam up in there.
Yeah. So this radius could just be too small for a
Hmm.
part to actually fit. It would just run into here and get stuck.
Hmm.
The other thing is, since this cone is not like a part of the conveyor belt,
Hmm.
uh, the parts are small enough. Even big parts, even just like a tile or a
Yeah.
plate, would be small enough to just wedge underneath of there. And that's
Hmm.
what it really wants to do. It doesn't want to defy gravity.
Right, right. Yeah.
So
So you have a lot of opportunity for things to land on there. And the gap there has to exist because it can't rub the belt. Wouldn't even work. And so, okay, so cool. So we've already identified a few flaws with the cone method. And then now at this point, I think you can move on to the next iteration, because from this point forward, iteration 3 kind of takes on the rest of the concepts from this one, if you like, unless you wanted to show something else here.
yeah, there's one more thing I do want to mention. Initially, I thought that it would be perfectly fine to evenly space all of the air nozzles that squirt the parts off the conveyor.
Sure.
But at our last meeting, you pointed out that if you have a longer or a wider part land on this conveyor, then it could be engaged by two air nozzles and it would go into the wrong bin or it would end up between two bins. So that was another thing I worked to address in the third version of the robot, was to have a greater distance between all these holes and to even have uneven spacing on some of them.
There's a couple of questions here that might be appropriate to answer right now here. I'm going to see if you're ready for one of these here. What happens if some tiny items clog up the holes? What do you kind of have to do with, like, so you on your V, I think this is in regards to the V channel holes as things vibrate through. If something clogs up, what do we have a plan for that?
So the holes that were meant to filter out the small parts, is that
Yes.
the... Yeah, so that kind of is my hesitation with even adding those holes at all. I almost am tempted to just say, well, we try out and see if we can make a machine that doesn't jam the small parts in the rest of it.
Good.
Because so the holes that you see right now, these are for rivets. The sheet metal I found was not long enough to make this entire channel with one strip, so I have them riveted together. But if we did try to filter out the smaller parts, I think it would have to be like, yeah, I don't really know. That's an excellent question. I think that it kind of leads me to believe that we just try to eliminate all the gaps in some other way.
So a different design, maybe less gaps between belts, and all that. So, or if we leave the holes and it does work good enough to eliminate small parts that we need to, it sounds like a person, an operator, is going to have to be the one to clean those up.
Yeah, and then maybe small parts that get jammed in the little holes just don't fall through. They just stay stuck in there. And yeah, somebody just has to pick them out.
Right. And there's another good question here about vibration in the feeder. I think we mentioned it before, but the V channel is going to be vibrated, and that's how the parts are going to kind of get loose down, and you're going to get the Brazil nut effect, that the smaller parts will go off the edge first, and some of the larger ones maybe are pulled out, manually or some other method. Any comment on the vibration?
Sure. So the vibration, I have some ideas. One, so this design is meant to be kind of flexible in terms of vibration, because I haven't really designed things in First Tech Challenge that are meant to vibrate. This is kind of new to me. I set up this motor to mount to the frame of the entire vibrate channel, and the idea is that it will shake the whole frame. But if we need more intense vibration, I have it kind of set up so that this thing will be mounted with springs, so that instead of being rigid, it will sort of bounce around at any suggestion of vibration on the rest of the structure.
Okay. All right. So some really good questions. Thanks for those questions. There's a few additional questions here that I will get to in a little bit here. You ready to move on to the next version?
Sure.
All right, let's go to iteration number 3. And I just saw it because you did show it, but I'm really seeing this for the first time today. So I'm going ahead and let you kind of talk about it, because it looks like there's definitely some changes here. So what did you keep and what did you change, or how do you want to go into that?
So I can start with the end conveyor.
Sure.
This I made much longer. This is actually now 8 feet long instead of 5.
Oh, wow. That is quite a bit. So 3 feet wide. Well, that's a lot longer.
Yes. I added, so I have 20, I think 18 or 20 holes in here so that we can choose what spacing we want on our pneumatic hoses.
Okay.
And they can vary at the end. Maybe the end ones are spaced out more than the initial ones, or vice versa, depending on what we find to work better. The second thing that I changed is I set up the camera to be on a more enclosed box. On the old version, it was just sort of floating, and somebody on our Discord pointed out that the lighting variation was going to cause problems with our artificial intelligence.
Mm-hmm.
And so I kind of wanted to enclose that more and keep different light from pouring in, but I still have to have sides open for parts to come in and out.
Mm-hmm.
I would say the most drastic change I made was to get rid of the double conveyor belts and the cone. So this is where I feel like we could probably do without shaking out the small parts back here, because there's really a lot of opportunity to like not have any gaps here. This turntable is just a turntable. It rotates around, and using centrifugal force, the Legos should go all the way to the outside of the cone, or of the plate. This is not a cone like the other one. I
Right.
might actually change it to be one later, but the manufacturing on the cone was going to be a bit of a challenge for us.
Mm-hmm. Yeah, well, one thing I'm going to point out is that your experience in building machines, robots already, you are taking into what it takes to manufacture it, not just design it and then decide whatever it takes to manufacture it later. You're thinking about this from end to end, and I really appreciate your experience there. It's quite valuable.
Thank you.
I have a challenge for you, and maybe you thought about this, maybe not. What happens if a round part, let's say a round 1x1 brick, like a little barrel, or even a 2x2 round brick, lands on the? How is it going to drop? Do you expect it to drop without rolling off of the belt? What do you think is going to happen?
Okay, so yes, I have thought about this. I originally thought of changing this conveyor to be positioned at a slope towards the back, but this was going to just be really annoying to design. So I kind of anticipate that I will be able to control the position of rolling things just by having little cleats or slots in the belt that they will settle into.
Okay.
But that will definitely require some experimentation as I move further in this process.
So would it be fair to say that on that belt you're going to have like a little channel that something lands into, and as the belt moves, if the brick is round and it rolls, it's going to roll in either one of those channels. When the air flies across that channel, it goes into its gutter and into its correct location.
Yes,
Okay.
the air will be more than enough to get them to come out of the channel.
So you'll be
Yes.
able to clear off the belt with the force of air that you have.
Yes.
Okay. And also in your air design here, you are able to accomplish a higher speed, correct?
Yes, so with the air, we aren't depending on like the uh, run position time of a servo motor.
Mm-hmm.
We also don't have to buy 16 servo motors and try to control them. The solenoids are very simple compared to a servo, and I think they'll be more reliable and also faster because you just puff that air and the part just goes flying.
Yeah. Okay. What else on your iteration 3 here are you excited about?
Um, Let me think. I think I covered pretty much everything I was
Excellent.
going to
Well, I
talk
think you've
about.
definitely reduced the manufacturing process. You've eliminated 2 belts. You don't need to manufacture a cone. You've also eliminated some of the gaps between parts with this version.
Yeah, I actually got rid of one of the motors too, so that will pretty significantly decrease our cost.
Mm-hmm.
Unless we just decide we need another motor, which we might.
Mm-hmm.
Because so this hopper here can handle what did I figure? It's 1,500 cubic inches, roughly, of parts, which I think seems like quite a lot, but if we find that it's just not enough to handle the bucket of parts, or maybe we find that it doesn't do a very good job of getting us one at a time, we'll probably need to build another stage behind it that is either an upwards conveyor belt or just a large bin. I like the bin idea because it doesn't take another motor, but
Right.
but we might need to expand the capacity of this at the beginning.
Some of those things could be a manual operator in the very beginning stages of this thing. We're trying to keep it to that what we do in the next 12 weeks here will result in an operational machine. I know today I was announced to me that the purchasing of materials has begun.
Yep, we officially ordered some parts.
All right. So one stage closer to it. There are some questions here. Before I get to those questions, Amanda, did we miss anything?
No, I'm ready for questions.
Okay, so we have a good comment here. And maybe you can give some color to this if you want. It says you could have a belt have a sensor that stops the belt moving to shoot the parts off. Interesting.
That is interesting, yes. So kind of the idea is that we wouldn't have to stop it, but because we want it to be so fast, yes.
Yeah, we want it to be fast. So what would happen if a part didn't go off of a belt?
Sorry, you cut out. Can you repeat that,
What
please?
would happen if we expect everything's going to blow off with the air, but what if it didn't blow off and it's still on the belt and as it goes through?
Yeah, so if it ends up being stuck on the belt and not fall off into the correct bucket, it will just go off the end, as per our current plan. It would be far more disruptive for the belt to reverse direction and send the part back.
Yes, everything would get out. Yeah, I agree. I don't want to have it go in reverse. I think just having a bucket at the end of saying things that didn't go well, especially in our first prototype here.
Yeah, we're designing custom circuit boards to drive the motors and solenoids, and we skipped the whole H-bridge thing that controls the direction of the motors because I just said all the motors are always going the same way all the time. And that decreased the complexity and number of components on the circuit board by quite a bit. So I think it was a fine decision.
Me too. All right, got a couple of questions here. What is the estimated size of the machine? I think we covered that a little bit. The length of the belt there is 8 feet. How wide is this?
I had drawings for my previous iteration, but not this one. The width is, well, that's not the entire width. I can get a better guess.
When you ask an engineer a question, how wide is the thing? They tell you by the millimeter.
562 millimeters, which is, it's about 18, 19 inches.
Okay.
And you like inches better?
I'm satisfied. So the other part of their question from the brick room is, could it possibly sort by color?
Could it sort by color? You could program it to sort by anything you want. I am not designing this for a specific type of sorting. It is entirely up to the software to decide how it sorts. The only limitation is that there's only 16 categories right now, so it wouldn't be able to perfectly sort by color. But definitely, if you wanted to sort by color, you just write an OpenCV program for the camera. You'd plug it into your board, program it onto your board, and tell it that you want to try to differentiate colors.
Right. And I know, and if you really caught on to what Amanda said there, it says she's not designing it to sort anything specific. It's just designed to sort. Doesn't even necessarily need to be Lego. It could be something else. Who knows?
Yeah, you could sort bottle caps with it if you wanted.
With the setup that you've got, as long as it meets certain material requirements, like limitations of the V channel and the oscillation cylinder. There, is that what that's called? What are you going to call that one there?
I called it the carousel.
The carousel. So it goes from the V channel to the carousel down to the belt. The distance it drops from the belt is a little concerning to me, but I think with those channels that you're talking about that are cleated onto the belt, I think you're going to solve that problem.
Yeah, also if we want to decrease this distance, I actually did. It used to be worse, and I talked to my dad today about the design, and he kind of said, "Oh, well, you don't want things bouncing." And
Mm-hmm.
I agree. I think it was just a version issue I had. This whole thing is like dependent on a sketch that controls all of the dimensions a little bit. Well, not
Mm-hmm.
all of them, but most of them.
Excellent.
Um, so I can pretty easily move this belt up until the parts practically just roll off the carousel.
Mm-hmm.
I mean,
I
there
think
is.
I see a lot of improvement here because you have it going from uh, the carousel to one belt and not from belt to belt. I think that's an improvement as well.
Yes.
All right. Another comment here says from Tom, it says oh, I just lost the comment. Here we go. Lots of lighting is good. So you can reduce the shutter speed to reduce motion blur coming in. So he's got a little smiley face there. So we agree. The cameras that we have are purchased from another project. Amanda kind of just came over one time and I was like trying to throw everything at her to and then equip her at this. She's like, I'm so far away from manufacturing, but I like this camera. This is pretty cool. I'll take that.
Yep.
So, all right. So Tom also has a follow-up comment right after that. Oh no, I've skipped one here from Vincent. It says, Vincent, can the gas come from a continuum of holes instead of specific holes? This way, depending on the pieces you want to sort at the time, the program could change the spacing accordingly. Were you able to follow that question?
I kind of do, but I kind of don't understand what you mean by continuum of holes.
So so he's talking about the air holes at the specific holes, depending on the pieces you want to sort at that particular time, changing the program and the spacing accordingly. So I think, yes, so the program can change pretty easily. There's going to be multiple holes, so we can adapt where the air nozzles are at, right?
Yes, you can.
Okay, and I think that's what we're going to do in the beginning. And you mentioned it once already, but they're closer together in the front, and they farther apart towards the end for the larger parts.
Yes.
Okay. So if we didn't address your question fairly, Vincent, please add another comment there. So there's a question: guardrails? Question mark.
For safety?
Maybe I'm not sure if that's a
Sure.
safety question or if it's more of a like. I think we were talking at the time about parts bouncing.
Oh, bouncing off the conveyor belt.
I think we addressed that question with the cleat channels. I think that's what it was addressed with.
Yeah, the cleats and also the moving the belt closer to the carousel.
Mm-hmm. All right. I'm going to read this question. Oh, there's more questions coming in. Thank you so much for all these questions. I love this. Yeah, so there's a question here. I'm not sure if we're going to be able to comment to it. I'm going to go ahead and pose it, Amanda. And if you are like need more clarity on the question, we'll get that. So, is the axis of vibration side to side, front to back, or eventually I would have thought front to back and up and down. So I think he's talking about vibration of the V channel.
Okay, I understand. Yes. So the vibration of the V channel is supposed to be up and down
Mm-hmm.
only. With
Okay.
well, I guess with maybe some side to side, but almost completely up and down.
Mm-hmm. And at the end of the V channel, do you expect to get a single part?
I do not expect to get a single part. I expect to get at most 3 parts together, and they should disperse on the carousel.
Is it because the carousel is moving fast? Why is it going to do that?
Yeah, because the carousel would be spinning quickly enough to.
So I see a little guardrail there on the carousel in case something happens and the part gets towards the center there. How large of a part do you anticipate will be able to fit through that little section right there between? I don't know what you would call that little section right there between those two bars at the exit point of the carousel. We'll call it that.
Oh, between here and.
Yeah. How wide of a part can you fit through there?
142
millimeters.
So, okay. That's a good question. I might have to adjust this. I have measured. I'm kind of anticipating the widest part possible to be 100 and what did I say? 180. That's like I think if I remember correctly, that is the width of a 1x16 plate.
Okay, so that's actually quite large. So if a plate came in that way, it would be able to fit through, and a 1x16 brick would also fit through.
Yeah, typically the long parts will not be sideways going through, and if they are, they will rotate because they'll run into this. But anything that's like those Technic wheels, those should be removed before they get here because they would just get stuck.
The big Technic wheels, yeah. So this does include a pre-sort. We're not going to stop the pre-screening that we do at the Great Brick Lab. We're going to be trying to pull out Duplo 16x16 plates, even smaller plates than that. The plate project is a great project, and it's a way for us to get plates to process quickly. Minifigs, electronics pieces, large, complete, possibly partially complete sets. A lot of this stuff is still going to have to be pulled. So there's still a human step before this. This isn't just to grab a bunch of bulk and throw it in there. There's still a human step. It's a quick scan, essentially, but there isn't a step here. And we're trying to decide if there's actually a sifting step that needs to happen before this to give the machine optimal operation. If it was a sifting step before this, it would probably be only one layer of sifting, probably holes large enough to fit some of the most larger parts, but eliminate the extremely large parts.
Yeah. Okay. I mean, also as a fail-safe, if something does just get jammed in here, like maybe in the future we could add a sensor for that. I don't particularly like sensors. I know I'm like a robot person, but just from my experience, a lot of sensors are really buggy.
Don't go around telling everybody you're a robot person, by the way. They might start to wonder.
Okay. No, I'm a real person.
Oh, okay. Good to know. All right. You ready for another question?
Sure.
And this one I know we don't have the answer for, but it's a good question. What is the estimate for the cost of the system?
What is the estimate for the cost? Well, I'm trying. So we just spent $400 at Amazon.
Oh, wow.
And we still, so that was like all of the solenoids and hardware. I mean, we still have to buy wood and sheet metal for this thing, and also motors and circuit boards. So I'm hoping that we don't exceed $1,000 for the first prototype.
Oh, wow. Okay, well, there you go. There's a very specific cost for you guys. Since this is open sourced, is the community's input on cost being taken into account? So I think the intent of this question is are we saying we're giving it out as open source, but we're not making it a very expensive machine to design? And I think you just answered that question by saying we think our first prototype is coming in under $1,000.
Yeah.
Okay. Now, that does not include any labor or any manufacturing skill that is acquired to make this machine. That's just a materials cost.
Yeah. So automation companies for sure would have to concern themselves with tremendous costs of engineers and manufacturers and builders and programmers and testing, but
Mm-hmm.
we're kind of as students working on this project. It's a big. It's kind of like first a little bit. It's like a volunteering opportunity that really teaches us a lot in a way, like free school almost. But I know it's not free, but it's just a lot of good learning, and I mean we don't need to get paid for it. We all want to see it work.
Mm-hmm. Mm-hmm. All right. And then there's a third question from Andrew Hammond. Is there a smaller option that would be less than 8 feet long?
Is there a smaller option? I I have designed this one. Not quite. I could finish it for you guys.
How about we stay focused on iteration number
But
3?
yeah, for now
So
the answer is no.
no, not really. Um, but this first iteration or this third iteration here that we're looking at here doesn't really work. It needs the length of the belt in order to distribute to bins. If we can figure out a way to shorten the belt and make it a smaller unit and have different layers of, how does it get to different bins? The sheer nature of the size of bins that we want to fill up that are blowing off of the belt is really where the spacing comes in. It also gives them space to work with some of the larger parts and kind of spread things out. Um, Let me ask a question here because I know that we consulted with each other to kind of come up with the length of this machine and how we laid out our bins. Um, if you were challenged to make a smaller version and then kind of compact with the same number of bins, do you think that we've limited you in any way? Or do you think that the length of that actually helps you kind of accomplish more?
I think the length definitely makes it easier to
Hmm.
sort into that many bins,
Hmm.
but it would be possible.
Hmm. With more
Um,
design.
yeah, with more design.
Hmm.
From my experience in FTC, I know that the smaller a thing is, the harder it is to design because things just
Hmm.
start crashing into each other.
So at the Great Brick Lab, if you've seen some of the other content on my channel here, you know that we have a pretty large warehouse. We did not take into any restraint of the size of the machine and the bins that we drop into. As a matter of fact, we said, go ahead, spread out, make it larger to manufacture or larger, easier to build, especially in this first version. And we completely understand that a lot of people are, whether they're out of their basement or a smaller operation, or maybe even just like a 300-400 square foot store, and they could benefit from something like this. This is just version number 1.
Yes.
Okay. Um, do we know what system/hardware we're planning to use for the control?
For the electronics,
I think that's where that question is. It says, what control system/hardware are you planning to use?
so we are our microcontroller is going to be a Teensy 4.0. So if you've not heard of it, it's kind of like a very small Arduino board. And they're fairly cheap, um, and very versatile. For example, we have used Teensy to try to make an automatic lawnmower for our yard. So you can do just about anything you want with the Teensy. Um, and then in addition to that, like I said before, we're working on custom circuit boards for the solenoid and motor control.
We can talk about the robot lawnmower in a different stream. I think that might be something we do. All right. Could multiple parts potentially lie directly behind each other, or is that taken into one of the steps?
Um,
Let me answer this question. So, this is from Tom. I think there's a potential that parts are attached to each other just as likely as they're lying behind each other. And so the answer is yes, because we're not necessarily going to take a step where everything is taken apart. One of the uh, items that when I met with Amanda last on site, we had talked about, do we have to have a person taking all the Lego apart, making individual separated pieces? And I really don't want to do that. I'd rather just feed the machine what we have and see what happens. So you're going to get a lot of attached, partially built things. My suggestion was to have something that either it flows off the back of the belt. It just kind of says, I don't know what this is. It doesn't fit any of my models. Just throw it off the end, or maybe eject it from the beginning. I don't know where she's going to land with that. And if you're not ready to discuss that yet, Amanda, we can just say we're not sure yet.
Yeah, I was just thinking of having them go off the end.
Mm-hmm.
Unless there's some other category that makes more sense to put off the end
Mm-hmm.
and have models shoot off with air, but I think going off the end is more reliable
Mm-hmm.
because the models will possibly be too heavy for the air.
Right. Yeah. Yeah. Or you can have weighted pieces that don't blow off the air as well. There's so many different possibilities. So we are building into the system, what parts do we need to eject? Multiple parts. The robot says, I'm not going to blow this out. I'm just going to eject it at the end. And even to that, whatever's left off at the end, then you've narrowed it down to a small group of parts that people need to take apart or potentially work with individually. I consider that to be sorted into some level. Okay. I'm not sure. You might know more about this better than I do. It says good solution for the Braun, Braun. I'm not sure if that's a specific reference. What about the brains? Okay, so he's making a reference to the brawn and the brain. So we got the brawn, the muscle, the actual machine doing the work. Now he's talking about the brains, development of the CNN. I'm not sure what CNN is.
That is an acronym for convolutional neural network.
Love it. I love it. Sounds very high-techy.
It does. That we haven't gotten too far into.
Okay.
Because we've onboarded a lot of people who are interested and work in companies that do AI. I have not. I watched some YouTube videos, read some TensorFlow docs. I know a little bit about it, but we're gonna be working on that mostly as a team of people who are more experienced with that. And
yep.
Yeah.
So the next live that we do, we're anticipating having a deeper conversation about AI. I don't know if we'll need a guest in that. It'd probably be a shorter conversation. Neither one of us have a great deal of experience. While mine is very limited. At least you knew what CNN stood for. So this is why Amanda is definitely here, but we may need somebody else for that conversation. But at least we can talk about where we're at with the AI. And then maybe we'll also definitely give an update on the CAD if anything changes there, but it could be a manufacturing week. Okay. Let's see. Can the gas come from a continuum of holes instead of specific holes? That was a reference. Problem with this is that you can have only one part at a time. Yeah. Okay. So Ralph was making a follow-up comment to the specific holes, and it's only one part at a time. It's definitely one part at a time, and we address what happens if parts are attached to each other, or if multiple parts come through, they're just going to roll off the end. And Tom followed up on his comment and said that the channels were for the rolling parts. All right. And he says, I think Ralph has a challenge here. Ralph Spriggs has a challenge. He says, I don't see how this design solves for that on the rolling parts, I think is what he's saying. Well, we'll just have to wait and see. Okay. Are you removing rubber tires during the pre-sort? So we do remove tires as a pre-sort, but we're going to definitely probably see a lot of tires still, smaller parts, tires like that. Are you prepared to handle tires on this machine?
Yes.
Okay.
I don't see why not.
Except for the really large ones, right?
Yeah.
And those are easy to see. But large wheels, tires, I will definitely just up for the challenge to see what this machine does with it.
As far as I know, those will be the Brazil nuts.
Mm-hmm. All right. Let's see. I am not seeing any other questions here. I see a few additions. Welcome, James, Vincent, Andrew Hammond was here. I don't think Pup Kiwi joined us for the call here. Let's see if there's any other additional questions in here. Vincent makes a comment. It says, and also, by the way, Vincent's a member of the team. Thank you for being on the Discord. We appreciate you so much. Could we have multiple chips so control of the solenoids and AI are separate?
Yes. So the teensy only controls the solenoids.
Okay.
It does not have the computing power to handle TensorFlow. So we will need a laptop computer or Raspberry Pi. If Raspberry Pis ever come back in stock again, we'll probably get one. But for the time being, we'll be using a laptop to run the AI.
Mm-hmm. Yep, I'm going to be using a laptop. That's exactly right, because it's hard to get Raspberry Pis, as we've learned. Okay. I feel like we are wrapping up here a little bit. I am going to start some closing comments, but before I do that, Amanda, did we miss anything?
No, I think we've covered all of our bases here.
So
and
if your
love the
question,
questions.
yeah. If the live chat will definitely be on the, after a while, YouTube posts a live chat, but there's also the after chat that will probably get a lot of comments and feedback on. First off, I want to tell everybody, thank you so much for being here to the live stream. And those that I've had conversations with one-on-one, and some of the feedback we've received from YouTube, not all positive, I will say. Some people are kind of for us and against us at the same time, and that is so appreciated. There are some heavy impacts if we can accomplish this, but the thing is, this is a huge challenge, and I don't think that we're going to get there with our first version. We'll get somewhere, and we're going to learn a lot. And in the next 12 weeks, we are anticipating having a working model, and we will show that. And I will give Amanda the authority and the decision of when she's ready to share this out inside of this CAD design. So she's one that put the work into it. It's been her goal to make this open source. I'm completely behind that. So what do we need? We definitely need your support. In the scroll, you've had the Give, Send, Go /Lego AI. If you give to the Give, Send, Go Lego AI, that money will not be used to manufacture our machine. The machine that's going to be housed in the Great Brick Lab, the money she was talking about spending, that will not come from that. That money is going to be put there for the artificial intelligence. If we bring in some professional help to help solve some of the problems, that's what that money will be to do. Anything that's given to Give, Send, Go /Lego AI will be used to develop everything that ends up being open source. None of that money will be used to manufacture a machine or a component, or purchase a component, or pay for any specific requirements that we have for our machine. So you're not giving to Great Brick Lab, you're giving to Give, Send, Go Lego AI, the world's Lego machine that we hope to be able to get to in the end. The tinyurl.com big robot AI link that you see there, which I hope is still working, is a way to get into our Discord. If you want to help us develop this through our Discord channel, we're getting pretty well organized inside the Discord. I would appreciate that very, very much. I've gotten people coming in with all types of experience, management experience of the tools and how to manage teams. I've got a marketing individual who's helping us out, and people who want to help us organize the Discord itself. If you want to help out, please come in. We'll get you a role assigned. We'll get you into a group. We need a lot of help with the artificial intelligence. Amanda's really, really capable at the CAD level, but if you have some ideas, some suggestions, some other inputs that you want to add, we're going to have 2 areas in there where we have problems in the AI, problems in the CAD that we have not quite solved yet. If you're great at marketing and you can help us create some publicity on this thing, like I said, this is not necessarily to drive productivity for me exclusively. Yes, the machine that we build will do that, but really we want to see the world have all the Lego be sorted. So I do have a few individuals that I want to do a special thank you to. So special thank you to Amanda, Phil at the Brick Room, who's really stepped up in a great way to help us out organizing our Discord and help us come up with some other new ideas about what the machine could be in the future. Just a brick in job of contributing, especially when it comes to the AI conversation. cdbbnny anonymously is helping Amanda with some of the things that she is not capable of doing in the AI space. Very, very skilled individual. And Vincent, who was in the chat, has been on board with this project for over a year, since the very beginning. Thank you guys so much for your contributions. Next week, we will be live again Friday at 7 p.m. So we're going to try and stick to a 7 p.m. schedule live. Amanda, how do you feel? Did we do today?
We did good. Thank you so much for having me.
Yeah. So we'll be here again in a week. If you could do me a favor and put a like on this video, share this out. Even if you kind of object to the idea of having all the Legos sorted and seeing, people have told me that if this works, you're going to increase the prices of the Legos worldwide. And I'm like, well, thank you for the confidence that you believe we're going to actually get a sorting machine that works. That's a great challenge to overcome, but they're more concerned about the cost of the Lego, saying that you're going to do it, Chris, and we believe in you, but we're really concerned about the price of Legos. And I really don't know what's going to happen in the end. So I'm going to go ahead and wrap this up. We're going to end the stream. Thank you, everybody who participated in the chat, and I will look forward to seeing you guys next week.
Yep, thanks. Bye.
Bye.